So let's look at the other side of quick quad number 5 here, the ACT number 10 at the top. All right, members of the fire department lean a 30-foot ladder against a building. Okay, the side of the building is perpendicular to the ground, to level ground, so the base of the ladder is 10 feet away from the base of the building. To ensure the nearest foot, how far up the building does the ladder reach? So this is a very typical Pythagorean theorem type question. You've got the ground, you've got a ladder leaning up perpendicular to a wall, right? So it told you it was a 30-foot ladder, and it told you we were 10 feet away. The ladder was 10 feet away from the wall. It wants to know how high up the wall is the ladder, right? So we need this side here. We're going to call it x. Again, this is perfect case for Pythagorean theorem. A squared plus b squared is equal to your c squared. So a plus b is equal to c. So 10 squared is 100 plus x squared is equal to 30 squared, which is 900. Solving for x, I'm going to take that 100 away. So we have x squared is equal to 800. Now I need to square root both sides, and the square root of 800, okay, we get 28.28. It asked us to round to the nearest foot, so we don't want a decimal. The next decimal is a 2, so we're going to stay put at 28. Looks like we're at C. All right, number 2, a square is circumscribed in about a circle of 7-foot radius shown below. What is the area of the square in feet? Well, I know they kind of drew a line away from the circle, but the radius also goes to the edge of the circle, which the circle is touching the square. So remember, a radius is halfway in between. So if that's a 7, this is also a 7, right? So the diameter of this circle, or the length of the square, will be a 14. And what's the area of the square? So every side is going to take on that 14. Area of a square is length times width. So 14 times 14 takes you to 196. Letter E. Not too bad. Number 3. The ratio of the side lengths for a triangle is exactly 12, 14, 15. And a second similar triangle to the first, the shortest side is 8 inches long. To the nearest tenth of an inch, what is the length of the longest side of the second triangle? So we can see that the ratio 12, 14, 15, small, medium, large. We are comparing the smallest to the largest. So it looks like the bigger triangle here, or the ratio of the first triangle, the smaller side is 12, the bigger side is 15, right? That's the relationship between the smallest to the largest. Since it's similar, we take on the same ratio. The other triangle, it tells you the shorter side is 8. Well, the shorter side of the big triangle is 12. Now we have a comparison to 8 over, we don't know what the largest side is. So now we're dealing with similar triangles. We're going to deal with our ratios and proportions. So again, we can cross multiply, or we find that unit rate. So what I'm going to do is I'm going to find out what it takes to get from 8 to 12. So 12 divided by 8 is 1.5, right? This is a ratio, so we have the same rate involved going from one number to the next. I'm going to use that same number to take care of my 15. So we're going to divide 15 by that rate that we found between 12 and 8 of 1.5, and it tells me that we should be back at 10. So x here should be a value of 10. That's kind of the quick, short way to do this, finding that unit rate. Sometimes that decimal is repeating, or it's kind of ugly to type in. So then you're going to have to use your cross multiplication skills. Regardless, both ways kind of get you there. Number 4, in the figure below, ABCD is a trapezoid. E lies on AD, and angle measures are as marked. What is the measure of BCD? So it wants BDC. So once this guy right here, right? So this, I'm just going to call it X so we can see a little bit better. So one thing about trapezoid, a trapezoid does have two sides that are parallel. So this guy is going to be parallel to this guy. So one thing you should remember from geometry class is when parallel lines are cut by a transversal, right? That's what line BD is going to insinuate, is going to be a transversal, that alternate interior angles are congruent, right? So if this angle is 30, that means this angle has to be 30, because they are alternating, right? They're on this side and then this side of the interior of the parallel lines, okay? So this angle and this angle will take on the theorem of alternate interior angles. Okay, well, why does that help us? Well, we've got this mess hanging down in here. Remember that a line takes on 180 degrees, okay? So this line here, right, going from one side to the other has to be 180 degrees. And I know 2 parts of the 3 parts, so I'm going to subtract them off. So 180, take away 30, take away the 105. Is going to leave me with what angle is hanging out in the middle there, right? So I'm going to take my calculator, 180 minus 30 minus 105, which tells me 45. Right, so this entire line is 180 degrees. I know 30 of it, I know 105 of it, which means I have 45 degrees left remaining for my angle X there. All right.